This would be part 4, no? Cross product. So vector algebra, part 4 of the class, okay, 4th class on vector algebra. And then let us look into what is cross product of two vectors. Lots of things is required, okay? Here. Cross product of two vectors. Cross product of two vectors, A and B. A is any vector, B is any vector. Then the cross product of two vectors, A and B, will be defined as, will be represented as A cross B. Cross product of two vectors, A and B, represented as A cross B. Suppose this is your vector A, and this is your vector B. So that A and B are two vectors. Let theta be the angle between them. And cross product of two vectors A and B is defined as magnitude of A times magnitude of B with the sign of the angle in between them. Okay? Followed by unit vector. Followed by unit vector. Magnitude of A scalar quantity. Magnitude of B scalar quantity. Sin theta gives you a scalar quantity. But this n cap is a unit vector which represents the direction. That makes A cross B to be a vector, not to be a scalar. Alright? Now, but if A cross B is a vector quantity, then it must have a direction, where the direction is represented by n cap. Now, let us check what is the direction of this A cross B. Let's consider this figure. This is your vector B. This is your vector A. Both of them are in different directions. Okay. So here, A cross B is a vector. Its direction is represented by n cap. Means n cap means it's a unit vector which will give you the direction of A cross B. Okay. Now, this A cross B is a vector. So it has a direction. I have represented that direction by n cap. Alright? Yeah, you can write any other thing also, any other unit vector. Now, how to find out the direction of this A cross B? Very simple. There are two different vectors here, A and B, in different directions. Okay? In one of the vector, you just put your hand. You just put your hand on the plane containing one of the vector. Your palm should be in a position. Your palm should be on a plane containing vector B, suppose. Okay? On any one of the vector, you place a palm in such a way that, okay, your palm lies on the plane containing this vector. Is it okay? Now you curl your four fingers. You curl the four fingers towards the other vector. Is it okay? Alright. Then where is the thumb pointing? Perpendicular to the plane containing A and B. Okay? That is the direction of A cross B. So the A cross B is a vector quantity, and the direction of this A cross B should be in a plane, or should be perpendicular to the plane containing both A and B. If A and B are two vectors, then see definitely A and B lies in a plane. So the direction of this A cross B will be in a direction perpendicular to the plane containing the two vectors A and B. No? A cross B laga direction to, it should be perpendicular to the plane containing the vectors A and B. Is it okay? No. Are you following that? No? To kinaga pisaribo. That means if your A vector and B vector lies on this plane, then the direction of A cross B will be perpendicular to the plane containing A and B, right? So either it will be in this direction, means perpendicular outwards, or it will be perpendicular inwards. Is it okay? Yes. So is it perpendicular outwards or perpendicular inwards? We will see using our right hand thumb rule. Is it okay? Yeah, right hand thumb rule. So what I'm going to do is, you place the palm of your right hand in the plane which contains vector B, and then you curl your forefingers towards the other vector. Then the direction in which your thumb is pointing gives you the direction of the cross product, A cross B. Is it okay? That means in this case, the two vectors, in this case the direction will be perpendicular outwards to the plane containing A and B. Is it okay? Yes. Are you following that? See, actually, if I say the direction of A cross B is perpendicular to the plane containing A and B, then that gives you two directions. One will be perpendicular outwards, one will be perpendicular inwards. Now a vector cannot have two directions, it must have only one direction. So we're going to find out the particular direction, only one direction now. So we're going to find out that direction, the right direction, using our right hand, okay? Just place the palm on the plane containing one of the vector. You curl your forefingers towards the other vector. Then the direction where the thumb is pointing gives you the direction of this A cross B. Alright? Yes. This is a magnitude of a scalar quantity. Magnitude of this scalar quantity, sine theta. These three are scalar quantities. Okay? But this is a unit vector. Unit vector represents the direction. So that makes A cross B to be a vector quantity. Alright? Now there are some results that we need to know, some small results. Derived results, let's say derived results. First one, derived results. First one is, see, if you are clear with all these ideas, then solving exercise will be very simple, okay? A cross B is a vector that we have understood. Alright? Second thing, when is A cross B equal to 0? What do you say? When will A cross B be equal to 0? Either if A is 0 or B is 0. That's one. No? Either if A is 0, either if A is 0 or B is 0, then the whole product will be equal to 0, right? Okay, so A cross B is 0 if either A is a 0 vector or B is a 0 vector. Second condition, theta is 0 degree or 180 degree. That means theta is equal to n pi. If theta is equal to n pi, if you can recall last year trigonometry, okay? That is either theta is 0 degree or 180 degree. Then A cross B, this product will be equal to 0. Okay? The next thing, the third one, if theta is 90 degree, pi by 2. If theta is 90 degree, pi by 2, then what happens to this A cross B? If theta is equal to 90 degree, then what will you conclude about this A cross B? What will happen to the product? Theta is 90 degree, means sine 90 degree is 1. So your A cross B product will become magnitude of A magnitude of B, and the unit vector. Is it okay? Yes. Number 4. Now let us look at the situation. See, in the dot product, okay, in the dot product, we have seen that, okay, let us recall the dot product. I dot I is 1, j dot j is 1, k dot k is 1. Otherwise, I dot j, j dot k, I dot k, everything is 0, right? But here, let's see what is I cross I cap cross j cap. Let us see that. J cap cross k cap, and then k cap cross I cap. And we can check its reverse also. We can check what is j cross I, we can check what is k cross j, we can check what is I cross k. We also need to see what is I cross I. We also need to see what is j cross j. We also need what to see is k cross. What will be I cross I? I cross I? I cross I means, okay, let us see the definition. I cross I means, okay, let's see what is A cross A mean. What is your A cross A here? According to the definition, magnitude of A times magnitude of A. That is magnitude of A square, right? A cross A means cross product of A and A itself. That makes the angle to be equal to 0 degree. And what is sine 0 degree? 0. That makes the entire product as 0. Understood? So I cross I is 0, j cross j is 0, k cross k is 0. Right? We have derived all right. Now, what about I cross j? What about j cross k? What about k cross I? For that, I need to draw a simple figure. Suppose this is x-axis. If this is x-axis, then its direction will be I cap. If this is y-axis, its direction will be j cap. If this is z-axis, its direction will be k cap. I want to find out I cross j, no? I cross j. I cross j. I is in this direction. So you take your, using your right hand, your palm should be in a plane containing I cap. Is it okay? And what will you do? You will curl your finger towards j cap. Where is your thumb pointing? Towards the positive z-axis. That is k cap. If it is towards negative z-axis, minus k cap. Right? Yes. So I cross j will be k cap. Are you getting me? Yes. Similarly, using the same concept, let me find for j cross k. See? Take your right hand and your palm should be in a plane containing j cap. You curl your finger towards k cap. Where is your thumb pointing? I cap. In the direction of I cap. So j cross k will be I cap. Is it okay? Then k cross I will be j cap. You can try that. Is it alright? Yeah. J cross or k cross I. K cross I. K cross I will be. This is your k, right? You curl it towards I, then it will be towards j. Okay. But if you take the reverse order, j cross I will now be perpendicular inwards now, minus k cap. If you take k cross j, then minus I cap. If you take I cross k, then it will be minus j cap. But see, in examination, you need to place your palm here and there. You have to curl your finger here and there, and the thumb you need to check, right? So which becomes very difficult for you. I have one trick. Okay? Just write I, j, and k. Arrange I, j, and k in the form of a triangle. Just arrange I, j, and k in the form of a triangle. if you go towards anti-clockwise, if you go in the direction of anti-clockwise means always positive. K cross I will be JK, positive JK. I cross J will be positive KK. J cross K will be positive IK. And if you go in anti-clockwise, this is easier to remember. Okay, this is just a technique. If you go in the clockwise direction, then I dot cross I cap cross K cap will be minus J cap. K cross J will be minus I cap. I cross or J cross I will be minus I cap, and so on. You try to remember in that order, then things will be more simpler. Is it okay? So number 4 is done. There are 8 to 9 derived results. The next, number 5, the next derived result will be how to expand this A cross B. A cross B to kinaka expand koribo. That's very important. Here, A cross B means this is the definition. If theta is not given, then you cannot use the definition. Then you have to find other means of finding A cross B, right? Is it okay? No. Suppose your A, this is number 5, right? Your A is any vector I plus J plus K. Your B is another vector 2I plus 3J plus 4K. Is it okay? And you want to evaluate A cross B. Then what do you need to do? A means I cap plus J cap plus K cap cross 2I cap plus 3J cap plus 4K cap. Is it okay? Scalars too, they don't follow cross product. So 1 times 2 is 2, but I cross I is 0. Nah? 1 times 3 is 3. I cross J will be K. And then plus 1 times 4 is 4. I cross K. I cross K will be going clockwise minus JK. So I'm going to write here minus JK. And we can do that product. Okay. So this is done, right? Now for this one. 1 times 2 is 2. J cross I clockwise. J cross I will be minus K cap, right? So minus K cap. Plus 1 3 times is 3. J cross J is 0. 1 4 times is 4. J cross K. J cross K will be I. Yes. So this is also done. Now for this one. 1 times 2 is 2. K cross I. K cross I will be J. Yes, clockwise. Plus 1 times 3 is 3. K cross J. Minus I. Very good. So minus I cap. And then K cross K 0, right? So we have I cap, this one and this one. I cap. Minus 4J cap plus 2J cap minus 2J cap plus K cap. But this is time consuming. So we have 1 trick again. In order to find out the cross product of A and B, we can do it by determinant expansion, which you have now masters. Okay, in this. The first row should be I cap, J cap, and okay. The second row will be the components of your vector A. What are the components of your vector A? 1, 1, 1. Next row will be the components of your vector B. 2, 3, and 4. And you always expand along R1. So if you expand along R1, then I cap 4 minus 3. Minus J cap, 4 minus 2. Plus K cap, 3 minus 2. That gives you I minus 2j plus k. So A cross B can be simply evaluated using this determinant. Is it okay? So that is number 5. What was number 6? Number 5 is done. Then the next one, the 6th derived result, finding the angle between the vectors A and B. Suppose you want to find out the angle between the vectors A and B. Then see. Okay, this is the, what is this? Definition of A cross B. Shall I take magnitude on both sides? Then magnitude of A cross B. Right? A is already in magnitude. This is already in magnitude. So then need to write. B is already in magnitude. Sin theta is already in magnitude. Right? Now the magnitude of unit vector is 1. Is it okay? So in that case, your sin theta will be magnitude of A cross B upon magnitude of A times magnitude of B. So that your theta will be given by sine inverse magnitude of A cross B upon magnitude of A, magnitude of, correct? So that is the 6th derived result. Okay? Now for the 7th derived result, let's see. We can find out the area of a triangle using the cross product of two vectors as well. Area of a triangle. Area of triangle, okay, if vector A and vector B are two adjacent sides of a triangle. If A and B are two adjacent sides of a triangle, then area of triangle is given by half magnitude of A cross B. How? How? Let's see. Okay, we have to look into it. How is it so? Otherwise, just knowing the result, you may forget, okay, or it may lead to some confusion. So whenever we have a result, we always need to show how, okay? Just give me a minute. So, let's see how this area of triangle is equal to magnitude of A cross B. Now, actually, A cross B means, A cross B definition is magnitude of A, magnitude of B, with the sign of the angle in between them, followed by your unit vector n cap. Right? If we consider only the magnitude, then magnitude of A cross B will be equal to magnitude of A is already in magnitude, B the same, sin theta is also in magnitude, magnitude of unit vector is 1. Okay? Now, I'm going to draw a triangle. Oh, here see, A is one vector, B is another vector with angle theta in between them, see. Now let me complete the triangle. So your triangle is completed. Now, shall I give the name of your triangle as ABC? Area of triangle means, actually, area of triangle means half base into height. Base into height. Okay, here this is not cross product, okay. Half base into height. Now, if I assume base to be BC, to be vector B, then I have to draw a line which is perpendicular to BC. Right? So AM gives you the height of the triangle. So in order to find out AM, I need to consider this right triangle. In right triangle, ABM, abang, sin theta will be given by opposite side upon the hypotenuse. Hypotenuse, magnitude, length. Hypotenuse means length of this vector, right? In that case, what will be your AM? Magnitude of A times sine theta, right? So your area of triangle will now be what? Half base into height, no? Base is magnitude of vector B. Base means magnitude of vector B. Height means magnitude of A times sine theta, correct? So that is half magnitude of A, magnitude of B, with the sign of the angle in between them. So half magnitude of A, magnitude of B with the sign of the angle between them. A magnitude of B. Simple. Is it okay? So this is your 6th or 7th derived result. 7th. Your 8th derived result, suppose you have a parallelogram where vector A and B represents the two adjacent sides of the parallelogram. Okay? Then if you complete the parallelogram, then using the same technique, the area of your parallelogram will be simply given by the magnitude of A cross B only. You can prove that using this result also. Is it okay? Like you can proceed similarly in order to obtain the result of this A cross B. So these are the 8 properties, 8 derived results of your cross product. And if you have a clear idea on with the definition of cross product and all these 8 derived results, then solving this exercise would be a matter of job only. Okay? Yes. Okay. So we have 8 derived results till now. Now there is 2 more important things that you need to know. Since we have already seen that I dot I is 0, right? Which is equal to J cross J is also 0. K cross K is also 0. That means a vector cross A cross A. If A is any vector, then A cross A is also 0. And A cross B is not equal to B cross A. A cross B is never equal to B cross A. See, definition says A cross B means magnitude of A, magnitude of B, with the sign of the angle in between them, and unit vector. Then what would be B cross A? Magnitude of B, magnitude of A, sign of the angle in between them, and the direction of this B cross A will be in opposite to that of A cross B. In that case, unit vector n cap will now become minus of n cap me. In that case, your B cross A will now become minus of magnitude of A, magnitude of B, sine theta with unit vector n cap. So which is equal to minus of A cross B. Is it okay? So their magnitudes are equal. A cross B, B cross A, their magnitudes are equal, but they have opposite direction. If A cross B has direction perpendicular outwards, then B cross A will have direction perpendicular inwards. Is it okay? Yes. Okay, so they are all together now 9 derived results. Is it okay? But for dot product, A dot B is equal to B dot A, because A dot B, the product of A dot B is a scalar quantity. But since A cross B cross product of A and B is not a scalar quantity, it's a vector quantity, so in that case we cannot say that they are equal, okay? And also, yeah, okay, A cross B is not equal to B cross A, okay, done.